Welcome to the Explainer. I am absolutely thrilled to guide you through today's topic. So have you ever looked at a highly detailed topographical map? You know, the kind I'm talking about with the precise coordinates, legends, and compass directions that guide explorers through those massive, really complex terrains? Well, today, we're going to learn how to read the ultimate map, the human body. As a focused learner, you already know that grasping the structure of something complex requires a rock-solid foundation. And in human anatomy, that foundation is built on an incredibly precise, universally understood language. By the end of our time together, you'll be navigating the geography of the human body just like a master cartographer. Okay, let's dive right into this. Imagine a doctor tells a surgeon that a patient has a severe scar above the wrist. What does that actually mean? Does above mean further up the arm, toward the elbow? Does it mean physically hovering over the skin? Is it on the palm side or the back of the hand? This simple, everyday phrase is just completely loaded with ambiguity. Now, in normal conversation, saying above works just fine. But in medicine, ambiguity can literally lead to dangerous errors. We need a standardized language that gives us absolute, precise GPS coordinates for the body, regardless of who's looking at it or what position the patient happens to be in. So here is our roadmap for today. We're going to establish our ultimate human map, decode directional terms, really zoom in on why the midline matters, specifically looking at medial versus lateral, slice our map into body planes, and finally wrap up with why anatomical language matters. Starting off with Section 1, the ultimate human map. Think about it. Every single map in the world needs a compass rose to orient the reader, right? Without knowing which way is north, your longitude and latitude mean absolutely nothing. Well, in anatomy, we have a very specific north. We have an absolute baseline that gives all of our medical coordinates their meaning. And that baseline is called the anatomical position. I want you to physically imagine standing in this exact stance right now. You're standing perfectly upright, your feet are shoulder-width apart, toes pointing straight ahead. Your arms are down at your sides, but crucially, and definitely don't forget this part, your palms are facing completely forward. This right here is the gold standard map of the body. And here is the secret. Whether a patient is lying on their stomach, which we call prone, or lying flat on their back, which we call supine, medical professionals always use directional terms as if the body is standing perfectly in this exact anatomical position. Moving right along to Section 2, decoding directional terms. Now that we have our map oriented, let's learn how to actually read the coordinates. The absolute easiest way to master these is by using the rule of opposites. These terms act as the body's GPS coordinates, and they almost always come in binary contrasting pairs. So once you learn one, you automatically know its opposite. It's great. Let's start with our vertical axis, superior and inferior. Superior, which is sometimes called cranial, simply means toward the head end of the body or higher up. Inferior, or caudal, means away from the head or lower down. And this brilliantly illustrates how we use these terms as relative coordinates. For example, your nose is superior to your mouth because it's higher up, but your pelvis is inferior to your abdomen. It's lower down, you see? You're always using these terms to compare the location of two different structures. Next up, we have our front-to-back axis, anterior versus posterior. Anterior, also called ventral, means toward the front of the body. Posterior, or dorsal, means toward the back. So thinking about our own bodies, your kneecap is located on the anterior side of your leg, but if you reach around to your upper back, your shoulder blades are located on the posterior side. A fun way to remember this, think of a dorsal fin on a shark. It's right there on the shark's back. Our next pair is a little bit unique because it's almost exclusively used for the limbs, proximal and distal. Proximal means closer to the point of attachment to the trunk of the body. Distal means farther away from that attachment point. Honestly, just think of the word distance when you hear distal. So, looking at your arm, your elbow is proximal to your wrist because it's closer to your shoulder joint. But your fingers are distal to your elbow because they're located at the absolute furthest distance from where your arm actually attaches to your body. All right, Section 3, midline matters. Medial versus lateral. I actually want to slow our pace down just a little bit here because we are entering the absolute core focus of today's explainer. We've talked about up and down, front and back, near and far on the limbs, but now we have to explore how anatomical structures relate horizontally across the width of the human body. And to understand horizontal relationships, we first have to draw a line in the sand, or rather, a line right down the center of the body. This is called the midline. It's an imaginary vertical line that drops straight down from the top of the head, right through the nose, through the belly button, all the way down to the floor, dividing the human body into perfectly equal right and left halves. This imaginary line is the absolute center of our anatomical map, and it acts as the anchor point for our next super important set of coordinates. And those coordinates are medial and lateral. Medial simply means a structure is located toward the midline of the body. Lateral means a structure is located away from the midline, out toward the sides of the body. So the crucial point to remember is that this relationship is completely defined by proximity to that invisible center line we just drew. Your heart, for instance, is medial to your arms, and conversely, your arms are lateral to your chest. Now, what's really interesting here is looking at some very specific and honestly sometimes tricky examples of medial and lateral. The big toe is the medial toe. The thumb is lateral to the other digits. Now, this perfectly proves why the anatomical position we talked about earlier is so important. Think about it. If you just stand perfectly relaxed, your palms naturally turn inward to face your thighs. If you measured from that relaxed stance, your thumb would look like it's medial, close to the midline. But remember, in anatomical position, our palms are facing straight forward. When you rotate your hands so your palms face front, what happens? Your thumb swings out to the far outside edge of your body. So anatomically speaking, the thumb is always lateral, and the pinky is medial. It's a total game changer once you see it. Let's take a quick breath and put all of these 3D coordinates together. We've covered the first 4 pairs in detail. Notice we've also got superficial here, meaning closer to the surface, like your skin, and deep, meaning farther inside, like your bones. By combining these binary coordinates, a medical professional can pinpoint absolutely any structure in the 3-dimensional space of the body. You could describe a tumor as being in the anterior, lateral, superior quadrant of the chest, and another anatomist will know the exact millimeter of space you're talking about. Section 4. Slicing the map with body planes. Let's see how all this builds into an even more advanced way to view the body. We have our 3D coordinates, but anatomists and modern medical imaging devices like CT scanners and MRIs often need to view the inside of the body by dividing its 3-dimensional map into 2-dimensional surfaces. We call these planes. There are 3 major ways to slice our map. First is the sagittal plane, which divides the body vertically into right and left sides. In fact, a mid-sagittal plane is a slice that runs directly down that exact medial midline we just spent so much time on. Second is the frontal or coronal plane, which slices the body into anterior and posterior, or front and back sections. And third is the transverse or axial plane, which slices the body horizontally, giving us a superior top half and an inferior bottom half. If you've ever seen a brain scan that looks like a cross-section viewed from above, you're looking at a transverse plane. Now, when we look inside those planes, we see the body elegantly organizes into cavities. There are 2 major divisions here, dorsal on the back and ventral on the front. The dorsal cavity is encased entirely in bone. That's the skull and the spine. And that's to fiercely protect the super delicate tissues of the nervous system. The ventral cavity on the anterior side, however, is quite different. It contains the thoracic and abdominal pelvic spaces. These cavities use special serous membranes that allow vital organs, like your lungs and your stomach, to physically expand and contract without distorting the surrounding tissues. It is just a brilliant feat of architectural compartmentalization. And finally, Section 5, Why Anatomical Language Matters. We've spent this explainer looking at imaginary lines, theoretical coordinates, and compartmentalized cavities. And I know it can kind of feel like a heavy vocabulary lesson. But it is so much more than that. We have to bring this back to the real-world stakes. Consider this quote from our source material at Lumen Learning. The purpose of this language is not to confuse, but rather to increase precision and reduce medical errors. All of these ancient Greek and Latin roots, anterior, posterior, medial, lateral, sagittal, they aren't just designed to make doctors sound unapproachable or fancy. They are a vital, standardized communication tool. When a surgeon is operating deep within a body cavity, knowing exactly what is medial to their scalpel and what is lateral to it isn't just medical trivia. It is the exact precision required to save a life and prevent massive spatial mistakes. So I'm going to leave you with this provocative thought to wrap things up. If directional terms are the GPS coordinates that prevent errors and allow us to understand the true miracle of human architecture, how well can you map the coordinates of your own body? The next time you feel an ache or a pain, try to describe it anatomically. Is it distal to your knee? Is it on the medial side of your arm or the lateral side? By applying this language to yourself, you don't just memorize textbook terms, you begin to truly understand the incredibly complex, beautifully structured map that you live inside every single day. Keep learning, keep exploring, and I will see you in the next explainer.